Alright, so this morning's Python presentation is the start of Python Essentials 2. So you won't get the course material coming up online until after you complete the summary test for Python Essentials 1, as that's the prerequisite for this course. So in the full module, we'll be discussing what modules do in Python, how packages work, and how Python installation packages, or pip, works. Now, packages and pip are in the second part of Module 1's presentation. So we'll be looking at 4 modules or chapters to P.E.2, the quick review of modules, bit of expansion, and then how we can use the packaging rules and directory structures and things like that to help navigate programming hurdles. We then go into Module 2 and look at those lovely exceptions, strings and less methods. Now, we've done a little bit on that in PE1, but this is in expansion of the material covered. Then we hit new ground with Python as an object-oriented language. And then we tidy it all up with Module 4 with, some miscellaneous areas, directory trees, files, using library modules. So just general round off. So modules form independent parts of the program. Under DevNet operations, you always divide your program up between developers. That way you can create the entire project quicker, because you got teams working on individual parts, and it spreads the load, makes it faster. You can then concentrate on debugging each module as it's a smaller part. This allows you to also, in the future, provide maintenance and upgrades by concentrating on particular modules and upgrading those modules. So if you remember, we can import modules into our program. Now, each module contains its own definitions and statements for executing the code within each module. So if you want to look at modules as a book that is self-contained, and there's a library available of all these modules in Python. It's open source, so there's a lot of predefined modules that you can borrow from the library and incorporate into your programming. So this gives you a wide range of functions, variables, objects and classes. We'll get into objects and classes a bit later, but it allows you great flexibility, and with a little bit of research up front and a bit of planning, you don't have to reinvent the wheel Okay, you can look through the library, find existing modules and import them. You can also modify those modules as you require. Namespace is like the scope of a name. So where that name is unique is within its namespace. So we need to understand how names affect our variables, our functions, and how we change the environment when we import different modules. Now, you can have variables or names in your code, and they may be replicated within an imported module. So it is easy to define exactly which name you're referring to, and that's by including the module in the function call. So the syntax for that is the name of the module separating to the function with a dot, and then the function's name. So an example of that is the sign function within the math module. So we can do that by importing an entire module, which we get all the functions within the module. But another way is to import only the functions that we want from the module. So the syntax for that's a little different. We, instead of just import and the module name, we're going from the name of the module, import the function. So this is specifically importing just a function that we want out of the module. This limits the scope of the duplication of names. Now, the benefit of importing the entire module is that we don't have to prefix the function's name. Now, the problem with that is duplication. If we import all the functions into our program, we've got to make sure we don't have our own functions and the imported functions duplicated in the namespace, because you're basically removing the directory service, if you like, or the uniqueness by importing all the functions into your main body of your program so that you don't have to call the module. So this requires you to import, have a very good understanding of all the function definitions and variables in play, and which ones are global, which ones aren't. So a workaround is to import the module with an alias. So you can change the name as it's imported. You can do this down to the precise functions. Now, you can do this repeatedly with commas to separate the phases. The benefit of using aliases is you can make unique names. You can also use it to shortcut the calling of the name. So instead of having a long name, which is the original name, you can put an alias in there with a shortcut key, so 2 or 3 characters. That would save the call function. When you invoke the function, you're not typing as much, which if you are calling the function a lot, it can save some typing. The other thing you can do is get a directory listing of what's available. Now, this is really good, especially when you're starting out. Remember, there's lots of modules out there, and you might want to work out what's available. So, by using a method called dir for directory, it gives you a sorted list containing all the names in the module. So you insert the module name that you want this directory listing created for as the parameter for the method. Now, random numbers aren't so random. The function that goes by the random name will produce the same number through its algorithm if it starts with the same seed. Now, what's the seed? The seed is the starting value that is injected into the algorithm to create a random number. Now, this number is a float between 0 and 1, and then it gives you a range. Now, there's some randomness in it because of the way it calls the seed. But you can actually stipulate where the seed comes from. Now, calling the random function in is following the same rules as importing any other module or function. So the module is random, then you need to specify the functions to be imported. In this case, we're importing random and seed from the random method. And you can see there the comma separating the functions. So the seed function is by default the current time. This is how it continually changes the output of the random. But you can override that default of the current time by specifying a particular value. Now, this value has to be an integer. So I would suggest you, if you're going to specify it, you would want to have it a variable that is changed each time you go to call it. This will help increase the randomness of the number. You then can specify ranges. So you specify the end, beginning of the end, beginning, end, or step. Where have we seen that before, I wonder? So this limits what's going to happen. And the last one is random integer. So start and stop, left and right. So that's the arc that it can randomize between. As we said, there are problems with this pseudo-random, is that you will get repeating values because there's only a finite number of combinations that it can generate. So choice and sample functions help reduce the repetitiveness. So choice allows you to pick a single number out of a sequence. So it's a drawn number. Whereas sample gives you a list of numbers, and what it will do is draw a set number of numbers. So you specify the sequence of numbers to choose from, and how many of those elements in that sequence to extract. So that your sequence is basically a list. So when you generate random numbers, if you're going to use choice and sample, generate a set of numbers and add them to a list. That becomes your sequence base. You then use that randomly generated list to take your sample or your drawn numbers out of. So modules work in your environment. Think of your environment as a pyramid. So you've got hardware at the bottom of the pyramid. It's the foundation that everything runs on. You've got the operating system that provides features that Python uses and interfaces with that hardware. Then you've got Python running on the operating system, which creates its own little bubble to run in. And that's where you execute your code. So your code is the top of the pyramid, and as mentioned previously, you step out of your code and call functions or features within Python. So it's stepping out of your code, doing things in Python, and then stepping back into your code and executing the next line. This platform allows modular systems to access the various layers of the environment. So one of the things you may need to do is to get an understanding of the environment that you're running in. So you may need to understand what the hardware is, what the operating system is, what interpreters you're running. So the platform will bring in different sets of information depending on these two variable set for the platform. So when the first one is set, it basically brings a common name in. When it's terse, it will bring in the briefest name that it can. Now, I would suggest you want to have a play around with these functions to see which one you would prefer to use. And it's always interesting to see what it pulls in. So, platform, it brings in the operating system and its patch information, what version it is. And then the bottom one, it's the shortest, it's the terse version. So have a play and see what results come back. The machine function brings information about your processor. Now, I find this quite interesting because it's not actually polling the hardware. It's still polling your operating system. How do I know that? Because my hardware is an i7. But when I originally set up this system, it was on an AMD 64. So just be aware of that one. So here we have the processor function, and we have the real name. So you can see the difference between those two functions. So I'll skip back. So the machine function is polling your operating system. So your system information of the operating system. Whereas the processor is actually getting the true information. It's just a little quirk. Something I discovered while I was going through and putting together this slide pack is when I was generating the results, having a play with how the various settings brings up different information. I went, that was interesting. Why is it calling up the AMD 64 for the machine when I know I've got an Intel chip in there? Alright, so system function is the great generic. Alright, so I'm running Windows. Doesn't tell me what version of Windows, it just says you're running Windows. So it's the generic name for the operating system. So you could get Linux, you could just get the generic name coming up. Version, so what version of operating system? So if you remember back to the first one, it was Windows 10, version 10.0.19.043, and then it had a service pack at the end of it. So this is just specifically the version information. So now you've discovered the hardware and the operating system that you're working in, you may want to extract the Python version. Now this extracts relevant information so that you know, because remember, there's a difference between Python 2 and Python 3, and they're not compatible. So you really need to know which version you're running on. So if you code something for Python 3, you may want to have a little check in there to check that it's running the correct version, or the version that has the features that you want to use. So this is how you bring in the Python implementation and the version attributes. So depending on which one you're running, so you can see here we're running the C Python now. That tells you which type of Python you're running. Alright, and then the version and the patches. Now, at the time of creating this slide pack, I was running 397. If I ran that same code now, I would get a different result. Why? Shocking. I did an update. There's version 3.10 out there now. And I was trying to... I discovered a slight problem when I was playing around with pip in the command console. Some of my pathing wasn't in place. So I updated. So, you know. So there's your Python group. Your major version, which will be 2 or 3. Your minor, so that's your revision. And your patch. Now, depending on your applications and that, depends on how they code their revision numbers. So, in summary, we went through a quick outline of the 4 modules that make up the Python Essentials 2 course. We discussed that there are 4 chapters, each covering a different set of areas, and the first 2 are expanding on areas that we've covered in Essentials 1. So we did a little bit of modules in Essentials 1, but this time we went through expanding on how we can import it, how the names can impact our program, because there could be duplicates, how we can overcome that using aliases. So that concludes this session.